Good morning. Today we are going to see some problems related with shear stress. So you can have these videos, that is GATE lecture number 7, which is in detail with this, and this shear stress exercise 3. So we will solve questions from last 5 years. So now we are with this first question, that is a beam of hollow rectangular section is subjected to a maximum shear force 50 kilonewton. Find maximum shear stress. Also draw the shear stress distribution across the section. So refer this figure. So now we have step 1. I will start from here only. So we have step 1, given data. Given data. So we have V is given, or V max is given, that is 50 into 10 raised to 3 newtons. And then section as shown in figure. Section as shown in figure. So we have step 1. Now we will go step 2, geometric properties. Step 2, geometric properties. So we have I is equal to PD cube by 12 minus BD cube by 12. Y bar I am not going to calculate because as it is symmetrical. So we have Y bar that is equal to 75 millimeters. So then we have B is 100 into 150 cube by 12 minus inner portion, and we have this as 80 and height we have 130, so minus 80 into 130 cube by 12. And from this we will get value of I, that is 13.48 into 10 raised to 6 millimeter to the power 4. So this is the step 2. Now we have step 3. Shear stress. And then we have formula tau is equal to VA Y bar upon IB. Now we have this, we have to calculate shear stress first. This is 1, 1. Then we have to find at this, that is where our width changes to 2. Then this will be neutral axis, which is 3, 3. Then we have here where we have 4, 4. And then we have at bottom, which is 5, 5. Now, above 1, 1 and below 5, 5, we do not have any area. So we have tau 1, 1 is equal to tau 5, 5 equal to 0 because AY bar is 0. Then we will go tau 2, 2 and tau 4, 4 we have same. And here we are going to find out value of AY bar, and that is equal to 100 into 10. Now we are going to consider area above this portion. And we have this area. So this is 100 into, this is 10. And from center, we have to consider this distance, centroid and distance. So total we have 75 and we have to subtract this 5. So this becomes 70. So we have into 70, and that will be 70 into 10 raised to 3 millimeter cube. And therefore we will get tau 2, 2 equal to tau 4, 4 equal to we have 50 into 10 raised to 3. AY bar 70 into 10 raised to 3 upon I value we have calculated 13.48 into 10 raised to 6 into B. And we will have this value 259.64 upon B. Now we have two values of B. If we will see this section, so we have section like this. So we have one value of B just above is 100. This area we have taken. This is 100 and this is 10. So we have one's value is 100. So we can write tau 2 to tau 4 4 just above. And we have just above value of B is 259.64 upon 100. And it comes 2.59 Newton per mm square. And then we have just below tau 2 to tau 4 4, just below. And we have this value 259.64. And now we have B value. This is 10 and this is 10. So 20. So divide by 20 and this will be 12.98 Newton per mm square. And then we have tau 33, which is at neutral axis. And then first value will be as it is, A y bar. So this value remains as it is. So we have this as 70 into 10 raised to 3. And then we have to consider remaining portion. So we have total from this to this 75. Out of this 10, we have this portion. So this remains 65. And therefore we have plus 65 into 10 and y bar from center of this. So this will be 65 by 2. So into 65 by 2 and we will get value of A y bar and that is 112.25 into 10 raised to 3 millimeter cube. And then tau 33, which will be tau max, which is at neutral axis. And we have 50 into 10 raised to 3 into 112.25 into 10 raised to 3 upon value of I 13.48 into 10 raised to 6 and B we have 20 and we have this value 20.82 Newton per mm. And then if we will plot this bending stress diagram, shear stress diagram. So we have value, shear stress is always 0 at top and bottom. And bending stress is always maximum at top and bottom. So now I will plot this diagram. So now we have these values. So this is 1, 1. We have this will be 2, 2, 2 value just above below, and this is 3, 3. So we have 0 over here, then we have value at this point is 2.59. Then this value suddenly increases because our width decreases. We have this value 12.98. Maximum value we have that is at neutral axis. And we have this value 20.82. Then again the same value we have 12.98 over here. Then we have 2.59 over here. And then 0. So likewise we have to draw shear stress distribution diagram. And maximum value is 20.98. So now we will go another problem. Now you can see we have these two problems are same, that is in 2017 and through 2019. So we will solve only one problem out of this. So we will go for this. So we have given data. So UDL 30 Newton per millimeter. This is nothing but 30 kilonewton per meter. One and the same thing. Span is given 1 meter. And then we have section as shown in figure. Then we have, this is step 1. Then step 2, we have geometric properties. Step 2, geometric properties. And we have, this will be T section. So flange is given 125 by 25 and web is given 175 by 25. Now Y bar we have from top 125 into 25 into 25 by 2 from center to top plus we have 175 into 25 into from center of this till this. So we have this value 75, 175 by 2, and we have to add this 25. So we have into 175 by 2 plus 25 divided by, we have 125 into 25 plus 175 into 25. This 125 into 25. This value is 3125 and plus this value is 4375. And we will get this total value that is equal to 7500. And that will give us value from Y bar from top. And that value we have 70.83 millimeters. Then I moment of inertia, we have to go in the same way. We have 125 into 25 cube by 12 plus 125 into 25 into 70.83 minus 12.5 whole square plus 25 into 175 cube by 12 plus 25 into 175 in bracket 112.5 minus 70.83 whole square. And we have value of I that we got is 29.56 into 10 raised to 6 millimeter to the power 4. Then we have step 3 now. We have to go for shear force, maximum shear force. Maximum shear force is a reaction. So we have given this as 30 kilonewton per meter. And span is 1 meter. Therefore, V equal to R equal to WL by 2. And we have this as 50 kilonewton. Then we have step 4. Step 4, we have shear stress. And we know we have formula for shear stress, that is VA Y bar upon IB. Now we have, if we will go to this, so I will draw over here. So we have T section. And then T section, we have this value, we have 125, 25. And then this is 175, 25. So we have value, this will be 1, 1. Then we have this value at this will be 2, 2. Then we have neutral axis, and that neutral axis is at 70.83, which will be maximum value 3, 3. And then we have that is at bottom, which will be 4, 4. And then we will have therefore tau 1, 1 equal to tau 4, 4 equal to 0. Then we have tau 2 2. So we have to find first AY bar, and that is equal to 125 into 25 into now distance of centroid of the area from neutral axis, which will be 12.5, and we will have this value that is equal to AY bar 182.28 into 182.28 into 10 raised to 3 millimeter cube. And therefore we will get tau 22. We have 15 into 10 raised to 3. AY bar we have 182.28 into 10 raised to 3. I we have 29.56 into 10 raised to 6 into B. And from this we will get this value, that is 92.5 upon B. Now we have just above tau 22 just above. We have value above is 125. So 92.5 upon 125. We have 0.74 Newton per mm square, and we have tau 22 just below, and this value of 92.5 upon 25, and we have this value that is equal to 3.7 Newton per mm square. Now we have tau max, which is tau 33, which is at neutral axis. And then we have AY bar over there. So first AY bar will be as it is, 182.28 into 10 raised to 3. And we have to add a remaining of this portion. And then we have this will be plus 25 into 70.83 minus 25 into centroidal distance will be half of this upon 2. And we will get value of AY bar, that is 208.53 into 10 raised to 3 millimeter cube. And from this, if we will calculate tau value, then we will have tau max, that is equal to, so we have tau max equal to VAY bar, we have 15 into 10 raised to 3. AY bar 208.53 into 10 raised to 3. I 29.56 into 10 raised to 6. And B 25. And this value is 4.23 Newton per mm square. And now if we will plot this, then we will have this diagram in this fashion. So we have 0, that is at top and bottom. Then we have this value, if we will see, we got this value 0.74. Then value is 3.7 if we will go ahead. And then at neutral axis, we have maximum value, which will be 4.23, and we have 0 over here. So maximum value we have here, which will be 4.23. So this is shear stress distribution diagram. So we have to solve the problems in this fashion. Now we will stop here only. Remaining part we will see in the next lecture. Thank you.